of section 5, and we're also going to do section 6. So we're going to solve equations that have logarithms in them, aka logarithmic equations. So when you're solving logarithmic equations, you have to use all of those properties that we learned about. So for example, if it says plus, you're allowed to multiply, and the 2 you can turn into an exponent. If it says minus, then you divide, those kind of properties. So what we're going to do is condense this as much as we can. So first we'll put the two logarithms together with a multiplication sign. So we're going to have a log base 5 of 4 times x minus 1.
What did you, what?
So we're just multiplying 4 and x minus 1.
Oh. Sorry, I was not.
Which you, if you want, you can write as 4x minus 4. Now on the other side, I'm going to take this 2 and I'm going to make it an exponent of x. So instead of 2 log base 5 of x, we're going to have log base 5 of x squared. The inverse operation for something that has a log base 5 would be to use a base of 5 and then make these guys exponents. So to undo the logarithms, we are going to make these exponents of a 5. And then basically what happens is these cancel and you're left with 4x minus 4 equals x squared.
I don't understand how we can just like add whatever number we want.
We didn't add it. We used exponents. Whatever you do to one side, you can do to the other side, and as long as you do the same thing to both sides, you're allowed to do that.
Oh God.
So now
Okay.
This is quadratic. We're going to get this all set equal to 0, so we're going to subtract 4x and add 4, and then solve the quadratic.
Oh God. I did that wrong.
Moving the number here aside.
I tried to combine 4x x squared.
Oh, honey, no.
Not allowed.
No, Tristan, no.
I believe this factors to x minus 2, x minus 2.
It looks like
So
it.
x minus 2 squared.
And then, yeah,
Oh, wait.
and then set those equal to 0 and solve, and we get x equals 2.
You don't have to do it 2, comma 2.
Meh, it's just the same. It's still
Good
2.
try.
Hold on.
No.
After you get your answer, you want to check your solutions. What you're checking,
Do you use your calculator for that?
you can,
I'm going to.
but you don't really need to.
I really do.
What you're checking is to make sure that your answer aligns with the domain of the logarithm. So remember, we cannot find log 0, and we cannot take the logarithm of a negative number. So if you get x equals 0 or x equals negative 2, and then up here we have, like for example, log x, that would be a problem. Or if we got maybe a number that up here, if we subtract 1, would give us a negative number or 0. So for example, if we got x equals 1, when you go back up here and you plug it in, that gives us log base 5 of 0, which is bad. So what you're doing is you're taking your x and you're plugging it back into your logarithms that have x's in them, and you're just making sure that we don't get log 0 or the logarithm of a negative number. We don't get that for this one, so that means we're good. But otherwise, you might get some extraneous answers or extraneous solutions if you plug it back in and it gives you a negative or 0. Then that's bad. You would cancel those out. Okay?
Yeah.
Okay. Try. This one's a little bit different because there aren't logarithms on both sides. So what we're going to do is condense a little bit. So we're going to condense these two. First we're going to make the 1/2 an exponent of x.
Would you rather be like 1/2 up there or like negative 2?
Those aren't the same thing.
But yeah, aren't they?
No. 1/2 is the same thing as a square root. So we need this to be log base 3 of the square root of x.
See, I don't understand exponents. That's
I really don't either.
Maybe
I
just
really
keep
so
like a little cheat sheet next to you for a while,
I
and then
can't
you'll
have it on
figure
the
it out.
test.
I know, but I'm saying as you do like homework or something, you'll like start to remember it.
I don't know. I'm terrible at them though. It's kind of scary.
We also need to condense these two logarithms and put them as one logarithm. So that to do that, we would multiply because it says plus here. So when you're adding two logarithms, you can write that as one logarithm. So I'm going to multiply 4 and root x, so that gives me 4 root x. Just because typically we put the number in front of the square root.
You can't just like add them together.
Mm-mm.
Oh, because we're multiplying because it says a plus.
Because it's a logarithmic
Right.
property.
Right.
So here, we're going to do the same thing, but we just don't have a log on the other side. So it'll cancel this logarithm, and we get 4 root x. But over here, we get 3 squared, which is
Or
what?
7.
What? 7?
It is
7.
9.
9.
3 to the 2. 27. Tristan, you what? 3 times 3.
You're thinking 3 cubed.
Yeah.
And then this is a square root equation. So to solve, we need to divide by 4.
Oh.
So I get 9 over 4. And then I'm going to square
Square
both
it.
sides. So I get
I just wrote a V instead of
81 over 16.
Ew.
Look at what is that? Why would you do
I don't know, it's gross. Since it's positive, it's
that?
fine because the only logarithm up here that has an x in it is just a regular x, so that's not going to be
So,
extraneous.
what were you saying if it's negative?
You can't
If you
take the
didn't say
logarithm of a
extraneous.
negative number, and you can't take the log of 0.
So it'd just be like
So if you get,
x equals
if this,
the y third.
let's say your answer was negative 81/16, you go to plug that back in, you can't do that math, so that would be extraneous.
So you put a little line.
Yes.
But this one's good. This. Okay, so if it says minus, before you start to, divide stuff, you just want to make sure that there's no like things that could be exponents, but there aren't. So, but if there was like a number here or a number here, we would want to take care of that first. So we're going to condense using our quotient property. You're going to make x the numerator and then x minus 2 the denominator. And then we want to get rid of the logarithm, so we're going to use a base 3. So these cancel. I get x over x minus 2 equals 3 squared, which is what? 9. So let's write 9 there. Okay, to solve, you can just multiply x minus 2. So I get x equals 9 times x minus 2, which is 9x minus 18. And then I can subtract 9x, so that gives me negative 8x equals negative 18. And then when I divide,
Yeah, 18 over, or you get
yeah, 18 over
9 over
8,
4.
which simplifies to 9 over 4.
And it's not negative, so the answer is.
Oh, wait, but is it? So 9 over 4 is what as a decimal?
4, 2.9.
2.25.
2.25. You have to be careful with fractions because it's fine, but if this number is smaller than 2, then that would have made a negative
Oh, really?
logarithm. So you do want to be careful because when you look at a number like a fraction, you're not really conceptualizing what that number is sometimes. Like you want to think about it as a mixed number when you plug it back in to just make sure when it says minus something that this number is bigger than that number. So we're not taking the log of
So
the
you
negative
mean
number.
if it's bigger than negative 2.
Yeah, it has to be bigger than negative 2. Because if it was, say, 1.25 and then you didn't check it, you would have missed out.
So then what would
So
what
it's
number
fine.
does it have to be bigger than for the next question? 8?
Well, so for the next question, 8 is 8. That one's fine. It would have to just be bigger than 0. Because it's not subtracting. What's in the logarithm isn't subtracting anything. All right, try the